We're going to talk about solving radical equations. So basically, what is a radical equation? And a radical equation is any equation that contains a radical expression. So it's a variable under the radical. Okay, and we're going to use the power property of equality to solve these. So that tells me if I square both sides, of a true equation, the result is still true. So this follows along the same line as we can add the same thing to both sides, subtract the same thing, divide, multiply. For example, if I have a is equal to b, well then a squared will be equal to b squared. Or if I have the square root of x is equal to 4, and I square both sides, I get x is equal to 16. And these will remain true. So if I have a variable as a radicand, so I'm just a single variable under the radical, I need to solve this. So first I have to isolate. Wow, I cannot spell. Let's try that again. Isolate the radical. So this is 5 times the square root of x. So I'm going to divide both sides by 5. And that will leave me with the square root of x is equal to 7. Then I square both sides. So I square this, and I square that, and I get the square root of x squared gives me x. 7 squared is 49. Now, should I end up with something like this, I can't have a negative, so, oh, that's not true. Darn it. I'm lying. Please forgive me. Can't have a negative under the square root. Other than that, everything's fine. Okay, so let's work on some of these. I want to isolate the radical. So this is the square root of 8 plus 11. So I'm going to subtract 11 from both sides. And I'm going to get the square root of a is equal to 10. And then I'm going to square both sides to get that a is equal to 100. Here, I'm going to add 4 to both sides to get rid of that 4. And I end up with the square root of t is equal to 11. Square both sides. T is equal to 121. On this example, I've got two things happening. I'm multiplying and I'm adding, so I'm going to have to do a couple of steps. So I subtract 6 first. So 2 times the square root of x is equal to 22. Then I divide by 2 to get rid of that 2. And I get the square root of x is equal to 11. Square both sides. X is equal to 121. Okay, so that's how we solve them if it's a variable by itself under the radical. We can use real-world applications of this. The formula for the hull speed of a boat is h is equal to 1.34 times the square root of L, where h is the hull speed and L is the length of the water line on the boat, and that's the part of the boat that's touching the water. So if you have a boat, it comes, down and then the water. So it's this length under the water. So Idris and Sebastian are sailing in a friend's boat, and they measure the hull speed at 9 nautical miles per hour. We want to find the length of the sailboat's waterline. Apparently I typed that poorly, but so we're going to use our formula. H is the hull speed. We know that's 9. And we want to find the length of the water line. So I'm going to divide both sides by 1.34. And I get that 6.72 is equal to the square root of L. And I'm going to square both sides. And 6.72 squared is 45.16. So the length of the water line is 45.16 feet. Now, if you want to check, we want to check these to make sure we've done them right. We can plug that back in, and I can do that h is equal to 1.34 times the square root of 45.16. If I take the square root of 45.16, I get 6.72. And if I take that and I multiply it by 1.34, I get 9. And so we know we did it correctly. Another practical application, engineers use this for planning roads. V is equal to the square root of 2.5r, where that's the maximum velocity that a car can turn on an unbanked curve. So if we have a curve in a road that's not banked, V is the maximum velocity, and r is the radius of the turn. So if we have a road that's designed for a maximum speed of 65 miles per hour, we want to find out what is the largest radius that we can have. Or sorry, smallest radius, not largest. So we want 65 miles per hour. We're going to square both sides. 65 squared is 4,225. And when I square that, I get 2.5r. So I'm going to have to do some division now. Divide both sides by 2.5. And I get 1,690. So the radius of this turn must be at least 1,690 feet, which is a really not a very sharp turn. Okay. Sometimes we have expressions under the radicand, so we still need to isolate the radicand. Okay, and in this case, I don't have anything to add or subtract or multiply or divide because the addition or subtraction is happening underneath. So I need to just square both sides. And I get x plus 2 is equal to 16. Then I'm going to subtract 2 from both sides. And I get that x is equal to 14. I've got another here. I'm going to square both sides. And I get y minus 3 is equal to 225. Add 3 to both sides. And y is equal to 228. Okay. Sometimes we have a combination. When we look at this, we've got the radicand, and then 7 is being added to it. So we need to subtract 7 away first to get that radical by itself. Then we can square both sides. So I get a plus 5 is equal to 25. Subtract 5 from both sides, and you get that a is equal to 20. Now again, if we want to check this, we plug in the 20. Square root of 20 plus 5 plus 7 equals 12. The square root of 25 plus 7 equals 12. 5 plus 7 equals 12. That's correct. So you can always just plug them back in to check them. Here I have my radicand, and 4 is being added in the front, so I need to subtract 4 from both sides. and I have the square root of h plus 1 is equal to 10. Square those. H plus 1 is equal to 100. Subtract 1, and you get that h is equal to 99. On this one, I've got 3 times the radicand, so I need to divide by 3. And I have the square root of x plus 10 is equal to 24. Square both sides. X plus 10 is equal to, darn, I forgot my 24s, 576. Okay, subtract 10 from both sides. And x is equal to 566. Okay. And sometimes we get what's called an extraneous solution, and this is a solution obtained okay, so an extraneous solution, when we square both sides and we solve, and then we get a solution that doesn't hold true. Pardon my handwriting, but so this happens when we have variables on each side of the equation. So we have to check these. If you have a variable under the radical and a variable outside of the radical, you'll get an extraneous solution. So you have to check both solutions to see which one is actually true. Okay, so I'm going to square both sides of this to get rid of the square root. And I'm going to get k plus 1 is equal to k squared minus 2k plus 1. You can get that by FOILing. Okay, then I need to get all of my variables and everything set equal to 0. So first thing is to square both sides. Next thing is to set equal to 0. So I'm going to subtract k and 1 from both sides. So I'm going to get 0 is equal to k squared minus 3k, and the plus 1 and the minus 1 are going to cancel in this particular problem. And then the next thing I'm going to do is factor, complete the square, or use the quadratic formula. Now on this particular one, I'm going to factor because I only have the 2 terms, so I can factor out a k. And when I do that, I set each of these equal to 0. So I get k equals 0 or k equals 3. And then my last step, I have to check both. Okay, so I'm going to plug those in to my original, and I have 0 plus 1 is equal to 0 minus 1. Square root of 1 is equal to negative 1. 1 is equal to 1. Or I have 3 plus 1 is equal to 3 minus 1. The square root of 4 is equal to 2. 2 is equal to 2. Drop that negative right there. This one is not true. 1 does not equal negative 1, but 2 does equal negative 2. This answer does not hold true, therefore this solution does not hold true, and our only answer is k equals 3. So let's try another one. Square both sides. So FOIL this and you'll get x squared minus 6x plus 9 is equal to x minus 1. Subtract x from both sides. Add 1 to both sides. And you get x squared minus 7x plus 10 is equal to 0. Now, I can factor this because I look for factors of 10 that will make a 7, and that's 2 and 5. So this will be x minus 2 and x minus 5. Negative 2 times negative 5 give me a positive 10 and add up to negative 7. I'm going to set each of these equal to 0. And I'm going to get that x is equal to 2 or x is equal to 5. Now I need to go back and check that to find out which is true. So if I put a 2 in, I get negative 1 is equal to the square root of 1, so negative 1 is equal to 1. That's false. So it's not this one. And I'm going to just double check my other one. 2 is equal to the square root of 4. That's true. So my correct answer is x equals 5. One last example. Square both sides. And I get t plus 5 is equal to t squared plus 6t plus 9. Subtract t from both sides. And I'll do this in 2 steps on this one, just in case that was confusing by doing it in one. Subtract 5 from both sides. Now I can see that I can factor this, but let's just say that you don't see how to factor it, and we'll use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So I have negative 5 plus or minus 5 squared minus 4 times 1 times 4 over 2 times 1, which gives me negative 5 plus or minus the square root of 25 minus 16 over 2, which gives me negative 5 plus or minus the square root of 9 over 2, negative 5 plus or minus 3 over 2. So that's negative 5 plus 3 over 2, or negative 5 minus 3 over 2. So this is negative 2 over 2 or negative 8 over 2, which gives me negative 1 or negative 4. Okay, so if you didn't see the factor, you could use the quadratic. I still need to plug both of those in, though, to see if this is true. Negative 1 plus 5 is equal to negative 1 plus 3. So I get the square root of 4 is equal to 2. This is true. If I have negative 4 plus 5 is equal to negative 4 plus 3, I get the square root of 1 is equal to negative 1. This is not true. So my only true answer is negative 1, not negative 4. If you have any questions, please let me know, and I hope that that helped.